Okay, I have another problem on the board. Okay, let's look at this. Suppose Bubba has a pond behind his house that he advertises as Bubba's Fishing Emporium. He boasts that you'll catch at least 4 fish a day. You decide to try out Bubba's pond, and after 5 fishing trips, you feel slighted because you caught the following quantities of fish. Less than 4, less than 4, less than 4. Hey, you finally caught more than 4, less than 4. Out of 5 days, you got less than 4 times. You use the 5-step method to challenge Bubba's claim that alpha is 0.01. Assume the distribution is normal. Okay, so what did Bubba say? He said you catch at least 4 fish. And guess what? You don't believe that. You only caught more than 4 fish once. Now, this problem is a more realistic problem because in reality, you have to get your raw data, and from the raw data, you have to find your own mean and your own numbers. It's not given to you. Okay, so let's look at this. Let's continue. What type of test are we going to do? Get your flow chart out. Let's see. Is n bigger than 30? No, n is 5. Is the data approximately normal? We said to assume it's normal. Is sigma known? There is no sigma in the problem. There is no standard deviation whatsoever. So this is a t-test. Okay, and it's a one tail. What direction is this tail? Lower tail. Okay, alpha is one tail, 0.01 degrees of freedom. That's going to be 1, 2, 3, 4, 5. 5 minus 1 is 4. We reject if t. These two symbols are going to match when it's a one-tail test. Now, we have to take our t-test. We get 0.01 across the top, which is way out here, and we go down to 4. 0.01 and 4. The number you get there, I get 3.747. Okay, so let's do our computation. Now we use the letter T instead of the letter Z. And that's the only thing that changes. Now this number here, as I've always stated, goes right there. Then down here on the bottom, we got our standard deviations. Okay, what was the mean in this problem? We do not have the mean, do we? We have to compute, and for this problem, X bar. So if we do that, we take these numbers and add them all together. The summation of X equals 12. 1, 2, 3, 4, 5. X bar, 12 divided by 5 is 2.4. So 2.4 goes there. Now, what goes in the bottom? Our standard deviation. Did the problem give us a standard deviation? No, it didn't. So, do you remember how to compute a standard deviation? Would you be able to do this on a test? Well, I do remember this. We need to add up all our squared values. 4 plus 1 plus 9 plus 36 plus 0, and that equals 50. So now we compute our standard deviation. We have 1 over n minus 1, which is 4. 50 minus 12 squared over 5. If you compute that out, you get 5.3. But if you remember, 5.3 is the variance. The standard deviation is the square root of 5.3, which equals square root of 5.3. It's not something I have memorized. I'm going to use that number right there. I rounded a little bit. Okay, so now we can put those values in here. This is going to be S 2.3. Let's make that die a little bit bigger. 3022 divided by the square root of n. N was 5. Okay, so we had to compute. Well, we didn't have to compute square root of 5. We didn't have to compute that. But we had to compute all the other numbers. Now, if we type this in, 2.4 minus 4 equals that, divided by 2.3022. Whoops. I got negative 1.55. Okay. Now, there's something I forgot to do. Does anyone see what I forgot to do? I forgot to mark that. That number should be 3.747. And I remember that and that both need to be negative because it's a lower tail test. Where does negative 1.55 land? Lands there. So again, failed to reject the null hypothesis. There was not evidence to accept H1 as true. Now, there's a couple of things I like about this problem. One is you actually have to get your data and you have to compute your own mean and your own standard deviation. In the real world, if you ever do this, you're going to have to compute your own mean and standard deviation somehow. We did it by hand here. You'll probably type it into a computer and the computer will have to do it for you, but you're not given that information. Also, look at this, what I pointed out earlier. You only caught more than 4 fish once. It looks like Bubba's lying to us. But look how far these numbers are away. Negative 1.5, negative 3.7. Those numbers aren't even close. This is well within Bubba's claim. You have to, for us to statistically find something, for us to statistically be able to reject the null hypothesis, these values have to be extremely different. I hope that this shows that, because just looking at this, no, you don't catch more than 4 fish very often at all. That's not happening. But statistically speaking, he's way within his rights to advertise that. Okay, well, there's that problem. I got one more for you, and then that's going to be chapter 8.